We are starting a brand new unit called exponents, radicals, and polynomials. So this is going to be new topics that we have not seen or learned about yet this school year. So go ahead and open your book to page 287. We are starting in lesson 19.1, covering exponent rules and the basic exponent properties. So our first learning target here is to develop basic exponent properties, and we're going to have a graphic organizer for this. And we're also going to simplify questions, problems, expressions that involve exponents. So if I have 3 to the 4th, this is called a power. 3 is the bigger number, the larger number, and that is referred to as the base. And then the little number is 4, and that is called the exponent. Now, what this means is this does not signify 3 times 4. This is actually 3 multiplied by itself 4 times. So it's 3 times 3 times 3 times 3. Which, if you plug that in, 3 to the 4th power, or 3 times 3 times 3 times 3, is 81. Okay, so if I had b to the 3rd power, or b cubed, that means b multiplied by itself 3 times. All right? We are going to skip this question and go straight to question 2. What is the meaning of 3 to the 4th power, which we just talked about? So 3 to the 4th power is 3 times 3 times 3 times 3, and that equals 81. What is 2 to the 8th power? 2 is my base, it's the larger number, and 8 is the exponent. So what this means, if I write it out as repeated multiplication, it's 2 times itself 8 times. And I want you to type that into your calculator. The answer is 256. Why do you think exponents are used when writing numbers? Well, exponents are faster, they're shorter, it's less amount of writing. So exponents make it easy to represent repeated multiplication or the product of repeated factors. I would much rather write this 3 to the 4th power here, or 2 to the 8th power, than having to write out 2 times 2 times 2 times 2 times 2. Look how much shorter this is in comparison to all of these 2's here. Okay, so exponents make it easy on us when we're trying to write out repeated multiplication. It's a little bit faster or quicker. Okay, go ahead and turn your page to 288. We're going to jump to question 6. And if we're looking, it says use the table below to verify the pattern. Write each product in the table in expanded form. So in my first column, I have my original product here, which is 2 squared times 2 to the 4th. Okay, in the middle column, the directions said that we're going to write it out in expanded form. So 2 squared is 2 times itself twice, 2 times 2. 2 to the 4th power is 2 multiplied by itself 4 times. So 2 times 2 times 2 times 2. And then if I count them up, I have 1, 2, 3, 4, 5, 6. So it's 2 multiplied by itself 6 times. So in the last column, we're condensing it back down into a single power. So that's the last part of the instructions here for this single power. So let's look at the second row. I have 5 cubed times 5 squared. So if I write out these first 5s, it's 5 times 5 times 5. 5 multiplied by itself 3 times. Then if I'm looking at the second part, I'm also multiplying it by 5 times 5. Now let's count it out. The base is the big number, and how many times it's being multiplied is the small number, is my exponent. So 1, 2, 3, 4, there's 5 of them. So 5 to the 5th power. This third column has x's. So x to the 4th power, if I expand that out, it's x multiplied by itself 4 times. So I have 4 x's, and now I need to multiply that by x to the 7th power. So expanded form here would be x multiplied by itself 7 times. So I have 7 black x's. Now I'm going to count them all up to get my total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. So x is the big number, which is my base, and 11 is my exponent, or my power, the little number. So what I want you to do is I want you to try to do the last column with the a's. So expand out, what does a to the 6th power mean? And expand out a squared. A to the 6th power is a times a times a. 6 of them. And I'm multiplying that by a times a, 2 of them, a squared. So count them all out. A is the base, the big number. I have 8 total, so that's my exponent. All right, here's what we need to do. Question 7, we need to look at the pattern from the table in order to fill in that box. So if I'm looking at the table, what do you notice from this first column here, my original product, what was given to us, and our third column, our final answer as the single power? What am I doing? What's the process here? So this is multiplication problem. That's what the word product means, and that's what this little black dot stands for, is multiplication. Am I multiplying 2 times 4? No, because 2 times 4 would be 8, and this exponent is a 6. Let me look at the next one. Am I multiplying 5 times 3? No, because 5 times 3 is 6, but my exponent is 5. So what actually are we doing here with our exponents? We're adding them, right? 2 plus 4 gives me 6. In the second column, 3 plus 2 gives me 5. In the third column, 4 plus 7 is 11. And the last one with the A's, I have 6 plus 2 gives me 8. And notice I always keep my base, right? 2 stays the same, 5 stays the same. I still have an X and I still have an A. So this is called the product, which is a multiplication problem, of powers, of exponents property. So when I multiply, notice I keep my base, which is this A, and what do we do with the exponents? We add them. So we take M plus N, and that goes in your box. So even though this is a multiplication problem, I am not multiplying the exponents. We're adding them together. So I'm going to go through this property on our exponent organizer, our graphic organizer of all of our rules, and I labeled it as a VIP because this is a very important paper. So the product of powers, just to remind you that product means to multiply, or it's a multiplication problem. Okay, our verbal description here, in order to multiply with the same base, we keep the base and we add our exponents. Go ahead and type that in or write that down. To multiply with the same base, we keep the base and we actually add the exponents. So symbolically, just straight from the book, a to the m times a to the n equals, it says keep the base, which is a, and add the exponents, m plus n. So let's walk through some examples of this, okay? So the first question that I want us to think about or complete is 2 cubed times 2 to the 4th power. So keep the base, which is 2, and it says I add my exponents, so 3 plus 4 is 7. So it would be 2 to the 7th power. And you can leave your answer like that. If I type this into my calculator, though, I can get a large number. 2 to the 7th power is 128. So you could also write equals 128, but I'm going to leave it like that for right now. Next example, and I want you to try to do this one on your own. X to the 8th power times x to the 7th equals, keep our base, which is x. And again, we're adding the exponents. 8 plus 7 is 15. Okay, last example. 3x y to the 5th power times 4x squared y to the 4th power. And you should have more room because your boxes should be bigger than mine. I'm going to write my answer underneath. So if I was ignoring all of my exponents right now, and I said, what is 3 times 4? You would tell me what? 3 times 4? 12. So if I have numbers, I'm going to multiply the numbers. Now I need to multiply my exponents, my other bases here. So the next base is x. This is a multiplication problem, but my notes say when I multiply, I keep the x, the base, and I add the exponents. If there's not an exponent here, what do you think it is? We assume it's a 1. So I have x, 1 plus 2. So that would be 3. And let's move on to the next base. I'm going to multiply, but my rule says when I multiply, I actually add the exponents. So 5 plus 4 gives me 9. So 12x cubed y to the 9th power is our final answer here. Okay, now we're going to move back into our book. Question 8 on page 288. I'm going to walk you through this. So it says use the product of powers property that we just covered in the table and in our organizer to write x with a fractional exponent times x with a fraction as a single power. So what's the base here? Are these bases the same? Yes, so I'm going to keep it. So it's x. And then what do we do with the exponents? We add them. So 3 over 4 plus 5 over 4. See if you can add those. These fractions have the same denominator, which is 4. So I can add them. So I keep the denominator. And then I add my numerators. So I'm adding 3 plus 5, which gives me 8. Ooh, but these 8 and 4 are both even. What's 8 divided by 4? 2. So x squared, or x in the 2nd power, is our answer here. Okay, now we are going to jump to the bottom of page 289, where you see example A. Bottom of page 289, example A. You can write this question down in the My Notes section of your book if you would like to, and write out the work just like I do. If it helps you can circle some things, underline things, box them in, because you might not have multiple colors like me. So this is a multiplication problem. How do I know? Because of the multiplication symbol. So I have 2 coefficients, 2 numbers out in front. 2 times 5 is 10. My next base here, I have x to the 5th times x to the 4th. And if I look at my notes, it says keep that base, which is x, and add the exponents. So 5 plus 4 is 9. There's my answer. 10x to the 9th power. also on the bottom of page 289, wherever you have room, could be the My Notes section of your book, I want you to try a new question that I'm going to make up. Here we go. 3. Try this one on your own. So let's multiply. 3 times 2 is 6. And then I'm going to multiply y squared times y cubed, which makes me keep the base of y. And what do we do with the exponents? Add them. So 2 plus 3 gives us 5. And that's my final answer. So you can get in the habit of circling it or putting a box around it so I can easily find it. And now again, we're going to jump to page 290. Where it says try these A through B. And we're just going to do question A here. You should have enough room to write underneath it. So go ahead and try to work through this question the best you can. So 4 times negative 2. Let's see what answer you can come up with. 4 times negative 2 is negative 8. Then I'm going to move on to my next base, which is the x's. So keep the x. This one doesn't have an exponent, so draw in the 1 so you don't forget that it's there. And it's 1 plus 2, which is 3. And my next base is a y, and I'm doing 4 plus 5, which gives me 9. And that's my final answer. Good job. Okay, we're going to skip B and C, and we're going to go to question 15, which again is a multiplication problem. And I want you to try this question on your own. See what answer you can come up with. Three times 5, 15. Then I need to look at my y's, and when I'm multiplying, I actually add the exponents. So 1 plus 2 is 3. And then look at the z's. 2 plus 1 is also 3. So that would be my final answer.